Welcome back. Continuing our critical thinking, chapter 1. We're in unit 1C, sets and Venn diagrams. So exciting. All right, let's start with definitions. A set is just a collection of objects. The members of a set are the specific objects within it. So we write sets by listing the members within a pair of braces. For example, let's make the set of G. All my grandchildren, there's Jeremiah and Elena. So Jeremiah and Elena are the members of this set. The set is specified by a capital letter of grandchildren. And we use these little squiggly brackets, officially called braces, but I'll probably call them squiggly brackets, to enclose the set. We use 3 dots to indicate a continuing pattern if there are too many members to list. And to close it all off, a Venn diagram is a diagram that uses circles to represent sets. Now, a Venn diagram was named after John Venn. He actually died 100 years ago in 1923, so he's what we call a modern mathematician because it was in the last 200 years that he was born. He was an English logician, studied at Cambridge, and he wasn't the first one to come up with this type of diagram. Actually, Leonhard Euler in the early 1800s had a version. They were Euler circles, and Auguste de Morgan also had a version, but John Venn's are the one that stuck around and that most people use. So let's do an example. Let's start with set notation. We're going to use braces to write the contents of each of the following sets. The set of countries larger in land area than the United States. B, the set of natural numbers greater than 5. All right, so the set of countries larger in land area than the United States, it's only Russia and Canada. So we use squiggly brackets and we list Russia, comma, Canada. We always separate the members with a comma and we enclose everything we can. Unless it's like part B, the set of natural numbers greater than 5. Natural numbers, those are our counting numbers. It starts with 1. So greater than 5, that's 6, 7, 8, and so on, right? The 3 dots are telling us and so on in this continued pattern because there's no way we could list all of them. All right, so our Venn diagram, we have a fence around the outside. It all starts with we're only looking at this area. We're only looking at what's inside the rectangle. So a nice rectangular fence, little border that tells us where we are. And then we'll have circles representing various sets. So if we have a circle, a set of mammals, then the area inside the rectangle, but outside the circle, is for non-mammals. If we have a subset, right, whales are a subset of mammals. So we have a smaller circle inside of our mammals circle, a smaller set inside of our set. Notice that the blue part that's outside of the whale circle, this is humans and dogs and whatever else mammals that are not whales, all right? All mammals that are not whales. So every region has something different going on. We need to pay attention to all those regions based on how the sets interact. We say the set whales is a subset of the set mammals, and we can represent it visually, which is more helpful for some people using Venn diagrams. So if we have 2 sets, we have the set of fish and we have the set of mammals. Notice that there is no overlap. The set of fish is disjoint from the set of mammals. This area here, all of this is animals that are not fish or mammals. So we got some reptiles in there, birds, that sort of thing. In our third Venn diagram, we have a set of doctors and we have a set of women. And since there are women doctors, there's overlap. The set of doctors and women are overlapping. So the blue circle is doctors. Everything outside of the blue circle is not doctors. The pink circle is women. Everything outside of the pink circle is not women. So in the yellowy, tannish area here, we have men who are not doctors. In this blue, I'm going to call that area 1. In area 2, we have men that are doctors, right? They're outside of the, let's call them male. Let's use female. So outside of the female, male doctors, Outside of the doctors, but inside the female circle, are females that are not doctors. And inside of this little football shape here, oh, it's almost football season, are female doctors. Whew. All right, so there's 4 regions that I just stopped labeling once I started talking, as you'll see happen frequently. All right, so let's talk about those Venn diagrams we just looked at. A may be a subset of B, or B could be a subset of A, meaning all the members of A are also members of B, like we saw with the whales that are a subset of mammals. Venn diagram. A may be disjoint from B, meaning that the 2 sets have no overlap or no members in common, like the fish and the mammals. If A and B are overlapping sets, meaning that the 2 sets share some of the same members. If A and B are overlapping sets, that's a poor sentence. I apologize. I didn't grammar check this ahead of time. Overlapping sets, all right, we're going to call this an intersection pretty soon. But that's how they could react. That's how 2 sets could interact with each other in a Venn diagram. Either A is a subset of B, A and B are disjoint, or A and B have some overlap. All right, so let's use Venn diagrams to describe the relationships between a few things. Democrats and Republicans, party affiliations. Draw a Venn diagram. Wow, I can't read still. Draw a Venn diagram showing this relationship. Interpret all the regions of the Venn diagram. Okay, so when we draw a Venn diagram, first we start with our rectangle. It's around everything. I have a set of Democrats, and I have the set of Republicans, and especially this time in the world, there is absolutely no overlap. The other regions outside of the Democrat circle, outside of the Republican circle, are independents and members of Liberal, Green Party, I guess Communist Party is still active in the U.S., a whole bunch of different ones. Okay, we might write this as a person can only be registered for one political party. So if you are a Democrat, you cannot be anything else, right? If you are a Republican, you cannot be a Democrat. So they are definitely disjoint. The region outside both circles represents the people who are neither Republican nor Democrat, other political parties, or not registered. All right, so let's draw a Venn diagram showing the relationships among the sets of natural numbers, whole numbers, integers, rational numbers, and real numbers. Now, if you've forgotten, the natural numbers, which we abbreviate with an N, that's the counting numbers. It's what we naturally start counting with. Whole numbers, which doesn't have a special notation, that's just 0. You add the whole, right? Just a whole. And then the rest of the natural numbers. Rational numbers. Are you ready for this? We actually call rational numbers a Z. It's a German word that I forget right now. But rational numbers are all fractions. All fractions A over B such that B is not 0. A and B are elements of whole numbers. Actually, B is an element of the natural numbers, and I forgot integers. Totally forgot integers. Look at that. Let's erase. Nope, I don't edit videos. I make mistakes, and students need to see mistakes. What do we got? Natural numbers, integers. That's all right, because that's actually integers, not rational numbers. Integers are plus and minus. Are whole numbers. Ooh, see how they're just kind of building on each other? Rational numbers. Those are all fractions, where A and B are integers. And B cannot be 0. Can't have a 0 in our denominator. Real numbers are, wow. Real numbers are every number you've heard of that doesn't include the letter I. Real numbers are, we got square root of 2, we got some pi, we have all the rational numbers, We have all the integers. We have all the whole numbers. We have all the natural numbers. We have all numbers you could think of, except complex. And real numbers. Okay, so that's what they are, so you don't have to go back and look at the brief review. All right, that's what our number sets are. Let's take a look. Here we go. So natural numbers, right, are contained within the whole numbers. Whole numbers are contained within the fractions, the integers. That's not fractions, integers, positive and negative counting numbers. I'm sorry, integers. I keep messing them up. Rational numbers, so that's all fractions, positive and negative fractions, which include integers, which includes whole numbers, which includes natural numbers. Real numbers holds all of those. So irrational numbers are right here outside of rational, but inside of real. And this area is for complex numbers. If you're not sure what a complex number is, congratulations. You may never have to know. They are real. Don't call them imaginary. They're complex. But we won't talk about them in this class. I'm sorry. If you want to know more, hit me up. All right. So categorical propositions must have the structure of a complete sentence. One set appears in the subject. The other appears in the predicate. Yep, you have to know English in order to know logic and math. For example, in the proposition, all whales are mammals, the set whales is the subject set, and the set mammals is the predicate set. We usually use the letter S to represent the subject set and P for the predicate set. So we could rewrite all whales are mammals as all S are P, where S is equal to whales and P is mammals. All whales are mammals. All S are P. All whales are mammals. That gives us the subset notation where S is a subset of P. No S are P. Okay, so this is the categorical proposition. Either all are or no are. So no fish are mammals. Fish and mammals are disjoint sets. Notice how the terms set us up for what's happening. Right? No is disjoint. All is telling us a subset. What about some? Some S are P. Some doctors are psychiatrists. Some S are not P. Some foods are not vegetables. All right, so some are, that's always going to be our overlap. Some are not, it's either going to be in one region or the other, but not in the overlap. Wow. Words, I'm telling you, woo. I have to know subject and predicate and speak right. Okay, here we go. Okay, the statement, some dogs can swim. We want to construct the Venn diagram. We're going to rephrase this as some dogs are animals that can swim. The reason we add are animals is so we could set up our rectangle. We're going to construct the Venn diagram where S, the subject, is dogs, and P are animals that can swim. So some dogs can swim. So some dogs overlaps the set of animals that can swim. Some dogs can swim. And that's where they put the X, but I got a squiggle there, so same thing. All right, smoking and pregnancy. This is not a judgment. This is an example given to me from Pearson. Consider the study summarized in table 1.1, which is on the next slide. It's an example of a two-way table. I'll show you when we get there. This study was designed to learn whether a pregnant mother's status as a smoker or non-smoker affects whether she delivers a low or normal birth weight baby. The table shows 4 numbers, which correspond to the 4 possible combinations of the baby's birth weight status and the mother's smoking status. All right, so here's table 1.1. It's a two-way table because we have information over here about the mother, and we have information up top about the baby. Now, notice there's no high birth weight. Seems like there should have been some of those, right? Maybe not. Whatever. Smoker, non-smoker. There's nobody with a big old bowling ball for a baby. Okay. Distribution of 350 birth weight status and mother smoking status. And there's a source. We're going to make a list summarizing the 4 key facts shown in the table. Then we're going to draw a Venn diagram to represent the table. And then based on the Venn diagram, we could briefly summarize the results of the study. This table, right, a two-way table, is sometimes difficult for people to understand. Right? So there are other ways of representing it. So notice, smoker, low birth weight, non-smoker, low birth weight. So we can label these as their, just like a multiplication table, right? Just like a times table. We could make a list summarizing the 4 key facts. 18 babies were born with low birth weight to smoking mothers. 132 babies were born with normal weight to smoking mothers. 14 babies were born with low birth weight to non-smoking mothers. And 186 babies were born with normal birth weight to non-smoking mothers. Well, this doesn't seem fair. They did 200 non-smoking and only 150 smoking. It seems like you should have, in order to have a good study, you should have had equal amounts of both. So now we want to draw a Venn diagram to represent the data. Okay, what did the data say? It said we had 18 smoking mothers with low birth weight. And that's what we're checking, right? Smoking mothers and low birth rate. Pick one or the other. You could have chose non-smoking mothers. But it's better to have the positive represented by the set. So low birth weight is what we were studying in smoking mothers. So those are our sets, smoking and low. Now, we noticed that there were 18 smoking mothers with low birth weight babies. There were 132 smoking mothers with normal birth weight. All right, so normal birth weight is outside of the low. But they're still smoking, so they're inside of the blue. Now we move over to non-smoking mothers with low birth weight. So non-smoking means they're outside of the blue, but they're inside of the low birth weight. And finally, non-smoking, so it's outside of the blue. Normal birth weight, 186, that's where they meant to put their arrow. We have that region on the outside. Notice there are 4 regions. Outside the circles, just blue, just pink, and the overlap of blue and pink. All right. The Venn diagram makes it easy to see how smoking affected babies in this study. Notice that the normal birth weight babies were much more common than low birth weight babies among both smokers and non-smokers. However, the smoking mothers had a lower proportion of normal birth weight babies and a higher proportion of low birth weight babies. This suggests that smoking increases the risk of having a low birth weight baby, a fact that has been born out of careful statistical analysis of this and other studies that were run better. All right, let's talk about blood types. Human blood is often classified according to whether 3 antigens, A, B, or Rh, are present or absent. Right, that's it. A or no A, B or no B, Rh or no Rh. Blood type is first stated in terms of the antigens A and B. Blood containing only A is called type A. Blood containing only B is called type B. Blood containing both AB is called AB. And blood containing neither is called type O. The presence or absence of Rh is indicated by adding the word positive where it's present, or negative where it's absent, or its symbol. Table 1.2 on the next slide shows the 8 blood types that result and the percentage of people with each type in the U.S. population, and we're going to draw a Venn diagram to illustrate it. Here we go. Okay, so remember the positive, that's the Rh factor. So for every A positive, we have to have an option of A negative, B positive, B negative, AB positive, AB negative, O positive, O negative. Notice these are our universal donors here, O positive. It works out that the people that are able to give blood the most, wow, universal donors, that's awesome. There's more of them. I happen to be in this population right here, A positive. I was always seeking A pluses in school, so it makes sense. That's how I remember it. All right, let's do it. Let's make a Venn diagram. Now, we have a circle for A, and a circle for B, and a circle for Rh positive. All right, so these are the labels of our circle. A, B, and Rh positive. These are the names of our sets. Now, okay, so positive is yellow. So A and positive, 34%. but it doesn't have any B in it. So this is our first region, and I'm going to label them 1 and 1. B positive, in the circle for B, in the circle for positive, but not in the circle for A. AB positive, it's in A, it's in B, it's in the positive. This is the one that's in the middle. O positive, A, B, O is the lack of them. O that is positive is here. So this is 4, the yellow region with no overlaps. A negative, in the circle for A, not in B, not in positive in RH. So this is area 5, just blue. B negative, area 6 is just pink. AB negative, it's in A, it's in B, it's not in the positives. And finally, O negative, it's not in A, it's not in B, it's not in positive. O negative, region 8. So if we have 2 sets, we have 4 regions of the Venn diagram, as we saw with the smoking and the low birth weight. If we have 3 sets, we'll have 8 regions. All right, 8 regions. Now, this work is copyrighted. I appreciate you watching. If you have any questions, let me know, and I will see you in the next video.